and then tomorrow we're going to kind of wrap up vectors, and then vectors lead us into this last section that we're going to do in this unit called complex form of trigonometric number, trig form of complex number, or something like that. But vectors are kind of like all right, so zero vector, guess what the zero vector is? It's just 0, 0. That's silly, right? And then we already talked about this, but like our standard way that we're going to write a vector is A1, A2, or the points are, components are. And we kind of talked about this last Thursday, but just to reiterate this, that if you have a number in front, or even a negative sign in front, you just kind of give that to both components. So negative A would be the vector components, negative A sub 1, negative A sub 2. If there was a 2A, it'd be 2A sub 1, 2A sub 2. Okay, today we're going to talk about changing things to unit vectors. Unit circle, we really like unit circle, things to be a unit of 1. With vectors, we really like vectors to have a length of 1 as well. So we're going to take vectors that aren't a length of 1, and we're going to make them a length of 1. So a unit vector is a vector that has a magnitude of 1, right? Magnitude means length. We have some special unit vectors that they call I and J, and they're just unit vectors on the x and the y axis. So the I vector just has components 1, 0. The J vector is a unit vector just up on the y-axis, so think about what its components would be. It would just be the components 0, 1. I think use I and J, I don't know. That's just what we use. And so this means that we can use I and J, instead of writing as components, we can actually write them using I and J, and it makes kind of working with them a little bit easier, and as we throw in some trig stuff, it makes that a little bit easier as well. So let me kind of show you where this comes from, and then we're just going to use it. So this is kind of sort of a proof of where this comes from. You like my meld between typing and writing? Because it's really a big pain. Like every time I typed it down here, and it just looks really stupid to me because it's just the sign on there, and I just didn't want to use the math stuff, so I was just writing it. So if you have a vector A1, A2, then you could rewrite that as A1, 0 plus 0, A2. That's not what we talked about last week of how we add vectors. If we added those together, we would still just get the components A1 plus 0 and 0 plus A2, just A1, A2. So I'm trying to get the I and the J vector in there. So think about if I took the A1 out front here. And again, kind of using what we talked about with the scalar, I just kind of took it out front. If I multiply that scalar in, A1 times 1 would give me A1, A1 times 0 would still give me 0, so that's still the same. And if I took the A2 out of here and multiplied it back in, I would still get the same thing. So 1, 0 is the I vector, 0, 1 is the J vector, so we could rewrite every vector in component form as just the first component I plus the second component times J. But also look at Full House. Just like it's on Netflix. It's like Full House. Full House. It was ridiculous at how they're trying to make it a real show, but there were all these references of just them being funny. I thought it was so funny. I was like, this is hilarious. You might decide. You might decide that college is we'll call it that. So, write in IJ form, really easy to do. You don't have to do this every time, right? The shortcut is the first component is just times I, the second component is times j. So if I have a vector with components 5, 2, in IJ form, that's just 5i plus 2j. what about the next one? 0, negative 6. You could say 0i. 0i. Since it's negative 6, I'm going to say minus 6j, which is the same as just negative 6j, right? You don't even need the 0. The other thing that you have to be able to do with vectors is you have to be able to find the magnitude, and remember the magnitude is just a length, and I gave you that formula for that on Thursday. Do you remember the one? The square root of a1 squared plus a2 squared. It's just like the Pythagorean theorem. So if it's in ij form, just remember you're just pulling those numbers out of there. This is your a1, this is your a2. So the magnitude here, do you remember the notation for magnitude? Yeah, with the 2 bars. But since this says v, I'm going to do v with 2 bars. I guess that would be v1 and v2. So it's just going to be the square root of 2 squared plus negative 5 squared. Or that would just be 4 plus 25, or the square root of 20. The exception to that will be when we talk about story problems. Obviously, if we're talking about story problems, give me a decimal problem. So magnitude, same formula, you just have to be able to pull out the numbers into magnitude. Okay, so the other thing that you have to be able to do is change a vector that's not a unit vector into a unit vector, but we want it in the same direction as this vector, 5i minus 12j. So, kind of 2 steps to this. Step 1 is you want to find the magnitude of the vector they give you. Right? It's not a unit of 1 right now. So just like we did on the last one, the magnitude of v in here is just going to be the square root of squaring the component. So that's going to be 25 plus 144, which happens to work out really nice, right? To be 13. And then what we're going to do to find the unit vector we're going to take 1 over the magnitude and multiply that by our vector. Which usually means you get fractions. So my magnitude was 13. If it's a square root, it's okay. But this one worked out really nice. It's just 1 over 13. And then my vector, I don't know if we want to write it in the 5i minus 12j, or we want to write it in component form. It depends on which way they want it. We could totally write it in component form really easily if we could just pull that out and say it's 5 and negative 12, which you can kind of see very easily. The shortcut here is you just take your magnitude, you just take each component divided by your magnitude. So my new components would be 5 over 13, negative 12 over 13. Or if you want to keep it in ij form, right, that's just 5 over 13i minus 12 over 13j. And what we've done is we've kept the same direction, but we've changed the units. And if you did the magnitude of this now, you don't have to. It should work out. But if you did the magnitude of this, I'm just going to show you up here. You don't have to write this down. But if I took this 5 over 13 squared, that would be 25 over 169 plus 12 over 13 squared would be 144 over 169. And by dividing it by the magnitude, we now have a vector of 1, right? Of magnitude 1. And so it's kind of a really cool way that you can take something that's not a unit vector, keep it in the same direction, but you can change it into a unit vector. And that's something that they want you to be able to do. questions about that. Tomorrow we're going to look at like the applications of this and solving problems with this, and that's really the real use of vectors. Physics, there's a lot of vector stuff in physics. Engineering stuff, there's a lot of work with vectors as well. So probably why it's not my favorite kind of math, because I avoided physics at all costs in college because my high school experience was terrible. So I just gave you 4 questions here, 5, 6, 49, and 50. If you still have questions on the other homework or questions on the quiz, like use your time wisely and ask me. 5 and 6 are just like the last ones, only they're in IJ form, and 49 and 50, I believe, are finding unit vectors for the problem. Okay?